Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video we will go through this topic 2 of the Cambridge International Chemistry 5070. So this exam or this particular syllabus is taken by 16 years old learners upon completing a 2 to 3 years course on this pure chemistry course, which is equivalent to the UK level IGCSE or GCSE chemistry, whether you're doing the core or the extended curriculum. So this particular subtopic continues on from the previous lecture tutorial, or what I call lectorials, on atomic structures, following electronic configurations and all those looking at the periodic table and knowing what is proton number, nucleon number, as well as their associated other names, such as proton number is also known as atomic number, and nucleon number is also known as mass numbers. So now we come to the final subsection. This is called isotopes. There are quite a lot of these learning objectives, but we'll go through them one by one in this lectorial. So this first one is basically just a definition thing. So we will need to know how to define isotopes. If you are unable to define isotopes when they ask you, that means you do not understand what isotopes are. So isotopes are atoms. They are different atoms of the same element. They have the same number of protons but different number of neutrons, right? And then 2.3.2 basically say that isotopes of the same element, they will have same chemical properties because they have the same number of electrons and therefore the same electronic configuration, right? The next bit is similar to what we've done previously on how the periodic table looks like and how we would normally express the particular atom in this particular format. But then we use this kind of symbols where the top bit represent the mass number, or what you will call the nucleon number. Okay, I've used the abbreviation NO, but perhaps I should write it out in full just in case, some of you would be thinking that it's alright to write it as such, but it's not really. The number at the bottom represents the proton number. I should probably use a different color ink to avoid confusion. So the bottom number there represents the proton number. I'd just like to highlight what we see in the periodic table, for example, for this one. So for carbon 12, all right, in the periodic table, we would see 6 on top and 12 at the bottom, and it told you that the atomic number is the proton number, and the relative mass number is actually the mass number, but because it's a relative atomic mass, it's actually an average mass number, and these things are shown in the middle. But we write as on the top left, we write 12 as a mass number and then 6 at the bottom and then carbon like this. This is how we write them on paper. This is how we are given in the periodic table. This is how we write them. I know it's very confusing. It's not the same way as you see in the periodic table, but this is the internationally accepted convention, and even Cambridge mentioned that in the syllabus you are expected to write it in this particular form and not exactly like in the periodic table, but in this particular format where the proton number is at the bottom left, not in the center, and the mass number or the nucleon number is on the top left and not like in the periodic table. Okay, so that is what this particular syllabus actually means. Use symbols of this particular type. You need to interpret it, the top bit being the mass or nucleon number, the bottom bit being the proton number, right? Of course, this is an atom. We talk about an atom where there are no overall charge, so the number of electrons equal to the number of protons here. Here is a bit tricky because this is an ion, so it will have gained an extra electron from the atom. So here you have 17 protons, but the ion will have 17 plus 1 because you have gained 1 electrons due to the overall minus 1 charge. Okay. Next bit is a definition. So you need to describe. Okay, so this is actually the definition of relative atomic mass. Relative atomic mass was given in the periodic table. Just to remind you, the periodic table that you will use again, relative atomic mass. there, okay, because this is the periodic table. It shows that this, you'll see that this is 35.5, whereas the rest of them are mostly whole number, okay, but it doesn't mean that there's 35.5 neutrons, simply because I mean, when you look at chlorine from the periodic table, you will have chlorine 1735.5. That is what you call the relative atomic mass. All right, what is important is you got to have the word average mass, all right, and it is compared to 1/12 of the mass of an atom. Because you're comparing atom, you have to talk about an atom. If you forget this, you will lose a 2 to 3 marks definition for atomic mass, which is this average mass of the isotopes, all right, relative to 1/12, 1/12 of a mass of an atom, carbon 12. We pronounce this as carbon 12, not 12 carbon, but we write them with the number on the top left to represent the mass number of this isotope carbon 12, all right. The last bit of this syllabus for the 2023 syllabus, which is quite new for the people who are doing the 2023 exam, is to do this particular thing is a calculation of the relative atomic mass. So we need to calculate this number, not state, okay, not stating, because if you're just stating, you can just get from the periodic table, but you can't, because they want you to specifically calculate. Okay, you calculate the relative atomic mass from the relative masses and abundances of the isotopes. So it means that some elements do not just contain one particular isotope, they have isotopes, plural, so more than one isotope. What are their abundances? How much is present? How much of the other one are present? What is the relative mass? Meaning from the mass number, not from the periodic table, but from the isotopes. I spent a bit of time going through the learning objective, but I'll now go through in details as we go through the lectorial itself, yeah? So isotopes are defined as atoms of the same element with the same number of protons, but different number of neutrons. Okay, this should have been written as 14 carbon like this, all right? And because it's carbon, you know the proton number is 6. This is the accepted convention. So when you learn this thing, it's easier if you remember it by examples such as carbon 14, 35 chlorine, 37 chlorine. So carbon also has carbon 12, etc., etc., etc. Okay. So each element has a unique chemical symbol because each element has a unique proton number. Proton number is the identity of the element. If you are the same element, your proton number does not change. Nucleon number or the mass number, which is this number on top there. So there is mass number or nucleon number. So it tells you the number of nucleons in the nucleus of an atom. It's the total number of protons and neutrons in the nucleus of an atom. Proton number is also known as atomic number. And then it just basically tells you the number of protons in the nucleus of an atom. And we know that for an atom, it has overall no charge. Because there's overall no charge, so your electrons are negatively charged, your protons are positively charged. What is important is they are equal. The number of electrons equal to the number of protons when you have no overall charge for an atom. This is exactly what I said. Your periodic table shows you in a particular format, all right? In a particular format like this. But then when we write on paper and when question give you, they will give you this internationally accepted convention, not in the middle, but on the far left, where the proton number is at the bottom, mass number on top. So be aware of your standard notation that's accepted internationally by chemists everywhere all around the world, by chemistry students all around the world as well. Okay, wherever you are, you will be learning similar kind of standard. Chemical reactivity, that's why we are doing chemistry. So isotopes of the same element, they are the same element, therefore they have the same proton number. Okay, they are atoms. Because they are atoms, Therefore, the number of proton equal to number of electrons, because we are talking about atoms, so they have no overall charge. No overall charge means the charge of the proton must balance on the number of electrons as well, due to the charges needed to be balanced, yeah. But different number of neutrons, that is what isotopes are defined as, yeah. Chemical reactivity, so we know that chemical reactivity, that is to do with, well, chemistry, chemical reactions. It's to do with the how many outer shell electrons do you have. If your outer shell electrons are the same, they have the same chemical properties. So this is the key bit. The question will ask you whether 35 chlorine versus 37 chlorine, are they the same? Are they different? How are they the same? Well, they have the same number of protons, they have the same number of electrons if we are comparing atom and atom, but they have different number of neutrons. But how about chemical reactivity? You can also think about the molecules. So we know that chlorine exists as molecules. So that means they can exist like this particular molecule there. So what does this represent? This means there are 2 times 35 chlorine atoms. There are 2 times 37 chlorine atoms. But when you do the maths, you can also see that there's another possible combination. Another final possible combination is actually 35 chlorine, 37 chlorine. Okay, so each of these, this one will have 1 chlorine 35, 1 chlorine 37. 1 time 35 chlorine, 1 time 37 chlorine. So there are three different kind of molecules of chlorine. Okay, so Cl2 molecules. There are 3 possibilities. Wait, both of them are 35, chlorine 35, 1 chlorine 35, 1 chlorine 37, or both of them chlorine 37. And these kind of questions, they can ask you in terms of rate of diffusion. Rate of diffusion depends on molecular masses, and the lighter you are, so 35 times 2, because you have 2 of these atoms, will give you 70. This one will give you 2 times 37, 2 times the mass number of individual atom, will give you 34. This one 1 times 35 plus 1 times 37, give you 72. So the fastest to diffuse to slowest to diffuse, this one will be the heaviest, which is 37 Cl2. This one will be the lightest, which is 35 Cl2. And somewhere in between will be the combination, whether you're 35 Cl, 37 Cl, or 37 Cl, 35 Cl is the same, because it's the combination of one of each to give you 2 atoms bonded together to give you a molecule, which is also an element. Okay. But the strange thing about isotope is that these 2 are not exactly the same atom, but they are similar, but they have different number of neutrons. So we still call this a molecule, we still call this a compound, not a mixture, because they're chemically bonded together. All right. Going back to my original point, they have the same total number of electrons, therefore the same electronic configuration, therefore the same number of outer shell electrons, therefore no changes to chemical properties. Yeah. How about things like physical properties? Physical property is to talk about boiling point, melting point. All right. So just now I talked about different rate of diffusion already, because they have different number of neutrons, so different mass number. Show or calculate MR, okay, to convince your examiners, yeah. I mean the one who are marking your paper. By right, you can also think about their boiling point, which can be slightly different, but we are not going to concern ourselves on those boiling point issues. Actually, I was wrong. Boiling point will not be affected, because boiling point depends on these are molecules. Boiling point depends on something else, which you will cover in the next topic, which is on chemical structure and bonding. All right. So I'll leave it there, and we'll continue on to the last subsection of these ideas on isotopes. This is very new. This is new in the O-level syllabus. It used to be in the A-level syllabus, and it seems that they have moved some more advanced stuff into the O-level syllabus because they feel O-level is not difficult enough. They want to challenge you even more, all right? So this is definition as we defined previously. We defined it previously. Relative atomic mass from your periodic table, is the average mass of the isotopes of an element compared to 1/12. The 1/12 is very important. And I have made a mistake again. It should be carbon 12, where the 12 represent the mass number. We pronounce this as carbon 12. Or you can write carbon and then dash 12, all right? You're comparing the mass of the isotopes, which represent an atom. So you have to compare it to the mass of an atom, okay? You have to remember there's an atom of carbon 12, not mass of carbon 12, but mass of an atom, one atom, okay? 1 equal to n atom, and the 1/12 is very important as well. So what does a mass spectrum means? Mass spectrum is the result. This is coming out from the machine. The machine is called mass spectrometer. So this is the machine we use to get this picture. So this is the machine. The technique is called mass spectroscopy. So the technique is the noun. The technique is called mass spectroscopy. The result which you get is called the mass spectrum. So question will say the mass spectrum of neon. So neon is a noble gas, is in group 8, for example, right? So it's got fully filled outer shell electrons, and it's got different isotopes, 3 peaks. What does 3 peaks mean? It's got 3 isotopes. What are the 3 isotopes? Well, this one is neon 20. How do I know it's 20? It's got 20 down there. This one is neon 21, and this one is neon 22. So 3 peaks means 3 isotopes of the neon, and each of these, they give you the abundances already given there in percentage. If you sum up the percentage, this 100 comes from 90.9 plus 0.3 plus 8.8. The sum of the percentage goes down there. And what have you done? You have done mass number times that. Mass number times percentage. And then you add. This is very important. You add them together because you want to know the sum of the individual isotope by how much you actually have of them. So this one you have 21, which is the mass number of this particular isotope, times 0.3, and here you have 22 times 8.8. I don't know why they use 0.0 there in this particular example, whereas, the question itself just gives 21, so you can just use 21. Put this into a calculator, do it correctly. If I were you, I would do one more step because I'm naturally very careless with my calculator. So if I just bring up my calculator, I'll do 20 times 20 times 90.9 plus 21 times 0.3 plus 22 times 8.8. I will get 2017.9 divided by 100. So I will show this step. Why do I think this step is important? This step I think is important because you can always go back and check your working, and when you get this step correct, you can recheck your working on your calculator. Okay, so by simply stating 1 or 2 more lines, it doesn't hurt you, because especially with calculation, it's very easy to make mistake. If we want it to 3 significant figure, so this is 1, 2, 3 significant figure, we look at the next one. This is 7, so it increased by 1, so there is 20.2. This is the 3 significant figure. It's the same answer as previously given. This is relative atomic mass. It's an average mass. That's why it's got decimal. And then your periodic table should show you relative atomic mass and show as 20 as whole number, because 20.2 is really close to 20. And in O level, your periodic table does not show you a lot of detail on the relative atomic mass to try and avoid confusing you, all right? But things like chlorine has got 35.5 there, okay? So let's try this particular next example, which is the last example in this tutorial. A sample of boron. So boron is the 5th element. If you know your first 20 elements, you know that boron is the 5th element. It's got proton number 5. It's in group, not 5, but it's in group 3, just above aluminium. And boron has this symbol B. It's got two isotopes, so 81.3% of boron 11, not boron 5 because this is proton number, this is mass number, and 18.7% of boron 10. You've got a lot of boron 11, a lot more, 80% compared to only 20%, close to 20% of boron 10. When you average them, the mass will be closer to 11 than 10 because you have a lot more of 11. When you look at the periodic table, boron there, you see the average mass is close to 11, okay, because you have a lot more of the 11. What are we going to do? We need to calculate a value. Calculate, all right? So it said calculate means you have to show your working. We want relative atomic mass, which is the average mass of blah 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 blah, all of which will come out in your exam because these are part of definition as stated in the syllabus. All of the particular important criteria, you have to get them correct. And then you also need to read the question, 3 significant figures based on what the question is asking for. So relative atomic mass is AR, relative molecular mass is MR. So relative atomic AR is equal to the mass of the isotope, which is 10, multiplied by the percentage, 18.7, close bracket. That one is done. Now you look at isotope 11, multiply by the percentage, use big bracket to close them up, divided by the sum of the percentage. You don't do divide by 10 plus 11 because you want the mass, you don't want the percentage being average. So you divide by the average. You divide by the total percentage. Like I said, it's very easy to press things on your calculator, but as a good practice, do the top bit and then write it out. I write it out, okay, and then the bottom bit should give me 100%. So know your calculator very well so that you can press your calculator correctly and very quickly. If you spend very long on your calculator, that means you don't know your calculator very well. That means, you know, you are not getting to know your calculator very well. Therefore, you are wasting precious time, okay, especially after you have used your calculator for a long time, yeah. So that's it in this lectorial. This is the last lectorial series on atomic structure, where we finish off with these kind of complicated looking calculation, but it's not too bad, all right? So just a side reminder that, you know, just because you know how to do it forward does not mean that they cannot ask you to work out the percentage if they give you the AR, or just does not mean that they cannot ask you to work out the unknown mass number of the unknown isotope. This is algebra if you know how to work forward, and this is your unknown. If you know this, then one of these could be unknown and you can do the math. And math, algebra, simple algebra are all from lower secondary mathematics in terms of rearranging equation and not being careless with your numbers. We'll do more of this in the checkpoint, as well as other work that accompanies this particular subtopic in class, or you will see in my other future tutorial videos. So thank you for watching, and I'll see you in the next video. Don't forget to subscribe, click the button on the bottom right, and yeah, share the channel with friends, chat group, and other people you think who can benefit from my chemistry tutorial channel. All right, thank you for watching again.